Welcome to the DIY Honda Garage channel. The Honda Odyssey, model years 2011 to 2017, can experience DTC diagnostic trouble codes B12E1 and B12E2, indicating issues related to the electric steering lock. DTC B12E1 signifies an internal error with the electric steering lock motor, while B12E2 pertains to a low-level failure of the MTRCUT1, an important component linked to the vehicle's steering system. The electric steering lock resides within the steering column and acts as a security mechanism, preventing unauthorized use of the vehicle by locking the steering wheel in place when the ignition is off. Both errors point to potential malfunctions that can lead to a loss of steering control or security function, which could affect the vehicle's overall safety. Therefore, accurately diagnosing these codes is crucial for proper functionality and safety assurance. Let's delve into a structured approach to troubleshooting these DTCs and ensure that the steering system operates optimally. DTC B12E1 involves an electric steering lock motor internal error, which is designed to immobilize the steering system and enhance vehicle security when the ignition is off. The electric steering lock motor is usually found within the steering column, where it interacts with the steering mechanism to ensure the wheel locks as intended. DTC B12E2 indicates a low-level failure of MTRCUT1, a critical relay that cuts power to the steering lock motor at the appropriate moments for operational control. If there is a failure in MTRCUT1, it may cause the steering lock to engage or disengage improperly, potentially leading to a loss of steering control. Both codes highlight the importance of the electric steering lock components in maintaining not only the vehicle's functionality, but also its safety features. There are several possible causes that could lead to DTC's B12E1 and B12E2. A common issue might be a blown number C18 fuse, which is positioned in the driver's under-dash fuse relay box and is rated at 7.5A. If this fuse is blown, it can interrupt the power supply to the electric steering lock motor. Additionally, poor connections at any point within the system wiring can also trigger these codes. Loose or corroded connectors can lead to intermittent supply issues. Another possible reason can be traced to faulty ground connections, such as an open or high resistance in the ground wire, or issues with the ground point G403. Identifying and addressing these causes is essential for restoring full functionality to the electric steering lock system. When dealing with DTC's B12E1 and B12E2, several symptoms may present themselves. One key indication is that the steering lock may engage incorrectly, either not engaging when it should, or failing to disengage, leading to difficulty when the driver attempts to turn the steering wheel. Additionally, drivers may observe warning lights illuminating on the dashboard, signaling a problem with the steering lock system, which could potentially lead to anxiety regarding vehicle safety. Another prevalent symptom could be the loss of power steering, making the vehicle harder to steer, particularly at low speeds. These symptoms should prompt immediate troubleshooting to ensure safety and proper vehicle operation. The first step in troubleshooting DTC's B12E1 and B12E2 is to clear the DTCs using the Honda Diagnostic System, commonly referred to as HDS. The HDS is an essential tool used by technicians to reset the vehicle's onboard computer and clear any present trouble codes. This step is crucial as it prepares the vehicle for a fresh assessment without past fault codes interfering with the diagnostic process. Upon completing this step, it is important to perform the subsequent checks outlined in the diagnostic procedure. Failing to clear DTCs may lead to confusion in identifying current issues, as older codes may still be flagged and influence the testing results. The second troubleshooting step is to perform a series of cycles using the engine start-stop button, moving through off, ACC, on, and off modes, and repeating this procedure 10 times in total. This method allows the system to reset and assess if the problem persists after a complete cycle. ACC stands for accessory mode, which powers electrical accessories but does not start the engine, while on mode activates all electrical systems. This process checks for any intermittent connections that may have been temporarily resolved during the cycling. It also acts as a method to ensure all systems are initialized properly. Precise adherence to this step is vital, as it sets the stage for the next phase of troubleshooting, which includes checking for active DTCs once again. The third step involves checking for DTCs again using the HDS after cycling through the engine start-stop modes. This is a critical checkpoint in the diagnostic process, as it verifies whether DTCs B12E1 and/or B12E2 remain active in the system. If these codes indicate yes, it confirms that there are ongoing issues that need addressing. Conversely, if no DTCs are present, it suggests that the problem may have been intermittent, possibly due to loose connections or other transient faults. In such cases, further inspection of related wiring and connectors should be conducted to ensure none were overlooked. This step allows the technician to efficiently route towards the next troubleshooting phase. At this stage, the technician should measure the voltage between body ground and electric steering lock 12P connector terminal number 3. This terminal is crucial as it relates directly to power supply for the electric steering lock. By measuring voltage, which should show battery voltage, the technician can determine if power is being sent to the steering lock motor. If battery voltage is present, it indicates that the electrical pathway is intact. However, if no voltage is detected, this may point to a blown number C18 fuse located in the driver's under-dash fuse relay box, or there may be an issue such as an open circuit or high resistance in the wiring leading to the lock motor. Addressing these conditions will bring clarity to whether the problem resides with the power supply system. The fifth step involves measuring the voltage at terminal number 7 of the electric steering lock 12P connector. This step focuses on the ground connection for the electric steering lock motor. The expected reading should be less than 0.2 volts. If the voltage exceeds this threshold, it indicates an issue such as an open or high resistance in the ground wire. A poor ground connection can lead to erratic operation of the electric steering lock system, causing either of the DTCs to arise. It is vital to check the ground connection at point G403, as poor grounding can severely impact the functionality of electronic components in the steering system. Adhering to this step ensures you leave no stone unturned regarding the integrity of the ground connections. In a final troubleshooting step, the engine start-stop button is pressed to ensure the vehicle is in on mode. At this point, the technician must again measure the voltage between body ground and electric steering lock 12P connector terminal number 12. This terminal is essential for monitoring the vehicle's electrical systems related to the steering lock function. Confirming the electrical system's functionality at this stage is critical, as it will provide insight into whether the electric steering lock motor and its related components are operational. Ensuring that the appropriate voltage is present here will indicate that the circuit is in good working order. Should there be any discrepancies in the voltage readings, further investigation into the steering lock motor and associated circuitry will be needed. Once all identified faults have been addressed, a thorough final repair verification is essential. This involves taking the vehicle for a test drive to monitor performance and ensure that the steering lock system is functioning correctly without any issues. During evaluation, remaining vigilant for any steering-related problems is crucial, as any anomalies could suggest that further adjustments or repairs are still needed. Additionally, it is important to utilize the HDS once more to check for any returning DTCs. A clean slate without the presence of DTCs signals that the troubleshooting process was successful and the repairs implemented were effective. This confirmation gives drivers peace of mind, ensuring both their safety and the vehicle's reliability. To prevent future occurrences of DTCs B12E1 and B12E2, implementing a routine preventive maintenance schedule is advisable. Regular inspections of the electric steering lock system can help identify potential issues before they escalate. This includes checking the integrity of the number C18 fuse and ensuring all connections are secure and free from corrosion. Maintaining proper grounding points is also crucial, as they play a significant role in effective electrical system operations. Furthermore, periodically testing the functionality of the electric steering lock ensures the system remains responsive. By adhering to these preventive measures, you can significantly reduce the risk of these errors reappearing. In conclusion, understanding DTC's B12E1 and B12E2 is vital for any Honda Odyssey owner or technician to ensure vehicle safety and functionality. Following the structured troubleshooting steps allows for accurate diagnosis and resolution of potential issues with the electric steering lock system. The process not only highlights key areas that may fail, including fuses and ground connections, but also sets a foundation for restoring proper vehicle operation. Additionally, performing regular maintenance can help mitigate risks associated with recurring DTCs. By combining thorough diagnostic practices and preventive measures, drivers can enjoy their Honda Odyssey with confidence in its reliability. Please like and subscribe to the channel. See you next time.